A pyramid begins long before its first stone rises. It begins as an idea, measured, marked, carried, and transformed into geometry on a scale almost impossible to grasp. Yet, scattered through Egyptian inscriptions are tiny symbols hinting at the mechanics behind that achievement. Hands, tools, numbers, movement. 10 hieroglyphs may offer an unexpected glimpse into that immense process. Let's read the clues they left behind. High above the Nile Valley at Deir el-Bersha, the limestone walls of Djehutihotep's tomb preserve one of Egypt's most revealing images of heavy transport. Painted during the Middle Kingdom, the scene shows a colossal seated statue resting on a wooden sledge, surrounded by an organized workforce. The monument itself was intended for Djehutihotep, a powerful provincial official of the 12th dynasty, and the image records far more than ceremonial display. It captures, in unusually direct form, a practical operation, a massive stone object leaving its quarry, crossing difficult ground, and being delivered toward its intended setting. The first detail to establish is scale. The statue is generally estimated to have stood about 6.8 meters high and weighed roughly 58 to 60 tons. It was carved from alabaster, most likely at Hatnub, a quarry region east of Deir el-Bersha. The accompanying evidence indicates that the transport covered a considerable distance, while the exact final destination of the monument remains debated. Earlier scholarship connected it with Hermopolis, on the west bank of the Nile, but later research has argued that the statue may instead have remained on the eastern side of the river. Then comes the most visually striking element, the workforce. 4 groups of haulers are arranged along ropes attached to the front of the sledge. The traditional reconstruction counts 172 men, 4 teams of 43. Their placement is not random. They appear in coordinated pairs, distributed along the ropes so that the enormous pulling force could be shared. One man stands immediately in front of the sledge, while others participate in the larger procession surrounding the statue. The image therefore resembles an ancient engineering diagram as much as a funerary painting. That arrangement leads to a straightforward deduction. The Egyptians did not need to make a 60-ton object weightless. They needed to reduce resistance and distribute force efficiently. A wooden sledge provided a broad, stable platform beneath the statue, while coordinated teams could generate a sustained horizontal pull. The problem was therefore one of friction, traction, synchronization, and ground preparation, and the artist included an especially important clue. A figure positioned at the front pours liquid onto the surface directly before the moving sledge. For generations, this detail was treated primarily as ceremonial. The liquid could have represented a ritual offering or a customary act accompanying the movement of an important monument. Yet, the physical consequences of wetting sand offer another interpretation, one that can be tested experimentally. In 2014, physicists from the University of Amsterdam studied the behavior of sand under conditions relevant to ancient sled transport. Their experiments demonstrated that adding an appropriate amount of water can substantially increase the stiffness of sand and reduce the buildup of a ridge in front of a moving sledge. In practical terms, properly wetted sand can lower the pulling force required. The result does not prove exactly how the Egyptians used the technique, but it provides a physically credible explanation for the liquid shown in the painting. This is where the scene becomes particularly valuable. The painting does not show some mysterious force overcoming impossible physics. It shows a sequence that fits ordinary mechanical principles. Reduce resistance, stabilize the path, distribute the load, and coordinate the workforce. The University of Amsterdam experiments suggested that such a method could significantly reduce the number of workers required compared with dragging the same sledge across dry sand. The image, therefore, may preserve a practical observation embedded within an artistic and ritual context. Yet, the interpretation is not completely settled. One difficulty concerns the exact nature of the liquid. Water is the most widely discussed possibility, particularly because wet sand behaves differently from dry sand. Earlier scholars also proposed lubricating substances, including oils or other materials. A modern tribological analysis of the scene emphasizes that the friction problem is more complicated than simply pouring liquid onto ordinary sand. The amount of traction available depends on the relationship between the sledge, the ground, the workers, and the degree of coordination within the pulling teams. That distinction matters because the scene is sometimes presented as if it were a complete technical manual. It is not. Egyptian artists were communicating several ideas simultaneously. The transportation of a colossal statue demonstrated the authority of Djehutihotep, the organization of his workforce, the fulfillment of a major commission, and the successful movement of an object associated with his identity and status. The surrounding figures, offerings, officials, and celebratory activity transform a practical operation into a statement of social power. The workforce itself also deserves careful interpretation. Older popular accounts frequently portray scenes like this as evidence of mass slave labor. The Griffith Institute offers a different historical framing. The workers are better understood as an organized labor force assembled for demanding projects rather than simply an army of slaves. Their disciplined arrangement in the Djehutihotep scene is consistent with a system requiring supervision, specialization, and collective coordination. There is another subtle clue in the composition. The men do not appear to be pushing from behind. They pull through ropes extending toward the front of the sledge. This concentrates attention on traction rather than brute force. The engineering challenge was not simply producing more bodies, but producing synchronized force without allowing the load to stall or shift. A 2016 mechanical study reached a similar general point. Its analysis concluded that moving such a massive load would require exceptionally effective teamwork, and that friction had to be reduced through some method. However, the precise surface arrangement remains uncertain. The study specifically cautioned against assuming a simple wood-on-sand or wood-on-wood configuration without additional evidence. Even the destination of the statue complicates the picture. For a long time, scholars followed the interpretation that the Colossus was transported toward Ashmounein, ancient Hermopolis Magna. More recent examination of the scene and its accompanying text has challenged that reconstruction, suggesting that the monument may have remained on the eastern bank. This does not alter the basic mechanics depicted, but it changes the geographical story surrounding the journey and reminds us that even seemingly straightforward Egyptian images can contain unresolved details. Alternative interpretations occasionally extend further, suggesting that the wetting technique reveals a sophisticated understanding of friction approaching modern engineering. There is a reasonable core within that idea. The Egyptians clearly possessed practical knowledge of materials, hauling, leverage, and coordinated labor. But extending the image into evidence of a fully developed modern-style theory of tribology goes beyond what the archaeological record can securely establish. The stronger interpretation is quieter. The Djehutihotep scene appears to preserve accumulated practical knowledge rather than a formal scientific treatise. A heavy statue on a sledge, a prepared hauling surface, organized teams, ropes, controlled movement, and liquid applied before the runners. Each component addresses a different part of the mechanical problem, and yet the painting preserves only the visible surface of that operation. The exact construction of the hauling track, the precise composition and quantity of the liquid, the organization of the teams beyond what the artist chose to display, and the final placement of the Colossus remain incompletely known. Even the statue itself has never been securely identified as a surviving monument. What remains is the image, damaged over time, reconstructed from early records, and still remarkably precise in the clues it offers about how an enormous mass of stone could be persuaded to move. The image of immense stone being drawn across prepared ground leaves behind an impression of organized labor, ropes under tension, teams moving together, and a monumental object slowly advancing toward its destination. But the machinery behind such an operation was never limited to muscle and timber. Somewhere beyond the visible labor, there had to be schedules, supplies, officials, boats, provisions, and written instructions. That hidden administrative world becomes remarkably tangible at Wadi al-Jarf, where thousands of years later, fragments of papyrus began revealing the logistical system surrounding the construction of Khufu's pyramid. The landscape itself is severe. Along Egypt's western shore of the Gulf of Suez, the ancient harbor of Wadi al-Jarf occupies a narrow coastal zone bordered by barren mountains. There are no monumental temples dominating the site, no towering statues announcing royal presence. Instead, the archaeology is scattered and practical. Stone galleries cut into the limestone, storage installations, anchors, pottery, tools, and traces of an ancient maritime station. The galleries are among the most distinctive features. More than 30 large chambers were cut into the rock, extending deep into the mountainside. Their entrances were originally sealed with enormous limestone blocks. Inside, archaeologists found evidence associated with organized storage and temporary occupation. The arrangement suggests that Wadi al-Jarf was not a permanent city. It functioned more like a carefully planned logistical facility, designed to support expeditions operating between the Nile Valley and the mineral-rich regions of the Sinai. That physical evidence establishes the first important point. This was infrastructure. The harbor was established during the reign of Khufu, the king traditionally associated with the Great Pyramid at Giza, around the middle of the 3rd millennium BC. Its position was strategically valuable because ships could move through the Red Sea toward the Sinai Peninsula. Expeditions could therefore obtain resources from distant territories and transport personnel and materials along an organized maritime route. Then, in 2013, the site produced an extraordinary discovery. French and Egyptian archaeologists investigating one of the galleries uncovered fragments of ancient papyri. Their condition varied considerably, but enough survived to reveal names, dates, quantities, and administrative details. These were not mystical, religious manuscripts or literary stories. They were working documents. Among them were records belonging to an official named Merer, a senior member of an organized Egyptian work team. His diary describes activities carried out during the final years of Khufu's reign. The documents are generally dated to approximately 26 BC? No. The evidence places them around the 26th year of Khufu's reign, in the 3rd millennium BC, roughly 4,500 years ago. This distinction is important because the records provide something rarely available for pyramid studies: direct testimony from an individual involved in the transportation of construction materials. Merer's team appears to have been involved in moving limestone from Tura toward the construction zone at Giza. The papyri record journeys, destinations, quantities, and administrative exchanges. They also mention officials connected with the royal administration, including an important figure named Ankaf, who appears to have held a senior position during the project. The implications emerge gradually. If Merer's records describe the movement of limestone toward Giza, then the Great Pyramid was not simply an isolated monument rising through anonymous labor. It belonged to a wider logistical network. Quarry workers extracted stone. Transport crews moved it. Boat crews navigated the Nile and associated waterways. Administrators measured supplies. Officials coordinated schedules. Food and equipment had to reach workers at precisely the right locations. The pyramid therefore becomes easier to understand as a logistical organism. This interpretation also helps place the Wadi al-Jarf documents within the broader evidence for Egyptian state organization. The papyri do not describe the entire pyramid project. They record the activities of one team during a limited period. Yet, even that narrow window reveals a bureaucracy capable of coordinating labor and transportation over substantial distances. One particularly valuable feature is the chronological structure of the documents. Ancient Egyptian administrators recorded dates according to regnal years, months, and days. Merer's diary consequently allows researchers to reconstruct sequences of movement rather than relying entirely on architectural inference. That changes the character of the evidence. A pyramid can tell us where stone eventually arrived. A quarry can tell us where stone originated. A surviving boat can demonstrate that ancient Egyptians possessed sophisticated maritime technology, but a logistical diary can connect several stages of the process into a sequence. The mainstream interpretation is therefore relatively conservative. The Wadi al-Jarf papyri are administrative records generated by a highly organized royal expeditionary system, and Merer's diary provides direct evidence for the transportation of limestone associated with Khufu's pyramid project. Alternative interpretations tend to focus on what the documents might reveal about the scale and organization of the workforce. Popular accounts sometimes transform the papyri into a complete blueprint for pyramid construction, but that goes beyond the evidence. Merer does not explain every technique used to raise stones, nor does he describe the entire architectural process. His records are more mundane, and precisely because they are mundane, they are valuable. They concern movement. The documents show that ordinary logistical decisions existed behind an extraordinary monument. A crew had to leave one place, reach another, collect material, return, report its activities, and receive further instructions. The grand geometry visible at Giza depended upon countless smaller operations that rarely survive archaeologically. There is also a useful comparison with the Djehutihotep scene. The painted Colossus showed the physical mechanics of moving an enormous object: people, ropes, a sledge, prepared ground, and coordinated effort. Wadi al-Jarf supplies another layer of the same broader system. The papyri reveal that large-scale construction depended not only on physical techniques, but also on administration. The scene shows the hands. The records reveal some of the paperwork behind those hands. Even the harbor's architecture reinforces this interpretation. The galleries were not monumental spaces designed for public ceremony. Their practical form indicates storage and logistical preparation. Anchors discovered at the site confirm maritime activity, while pottery and other objects indicate repeated occupation by expedition personnel. The physical and written evidence therefore converge. Wadi al-Jarf was part of a state-managed transportation network rather than an isolated coastal settlement. There are still boundaries to what can safely be reconstructed. The exact relationship between every activity at Wadi al-Jarf and the Great Pyramid remains uncertain. Not every papyrus discovered at the site concerns pyramid construction. Some documents relate to administrative matters, supplies, personnel, and expeditions whose precise purposes require contextual interpretation. Likewise, Merer's diary represents one work group rather than the entire Egyptian labor system. Alternative theories sometimes propose that the records demonstrate an unexpectedly sophisticated centralized economy capable of moving enormous quantities of material with remarkable efficiency. There is evidence supporting the underlying observation. The state clearly possessed substantial administrative capacity, but the surviving documents are too limited to reconstruct every institution involved or to establish a complete economic model. What they do provide is something more precise: They reveal a moment when monumental architecture becomes ordinary administration. A shipment of stone, a boat leaving harbor, a crew reporting for duty, an official receiving instructions, small entries connected to a structure that would eventually dominate the Giza Plateau. Seen alongside the transport scene from Djehutihotep's tomb, the papyri shift attention from the spectacle of construction toward the systems that made spectacle possible. The evidence points toward an organized network of labor, waterways, storage facilities, officials, and written records, while leaving some details of its exact scale and coordination unresolved. The surviving fragments are incomplete, but together they suggest that behind Egypt's most imposing monument stood something less visible and perhaps equally remarkable: a disciplined logistical machine operating one journey at a time. The papyri of Wadi al-Jarf revealed the administrative rhythm behind monumental construction: boats moving stone, crews reporting their journeys, officials coordinating supplies. At Hatnub, the evidence becomes more physical. Here, high in the barren limestone country of Middle Egypt, the ancient quarry floor preserves something unusually tangible: a sloping route cut into the rock, bordered by stairways and marked by inscriptions, post holes, and traces of the people who once worked there. Hatnub lies roughly 20 kilometers southeast of ancient Amarna, in an isolated desert landscape where pale stone rises sharply from the surrounding terrain. The region was prized for its calcite alabaster, sometimes called Egyptian alabaster or travertine, a translucent stone used for vessels, architectural elements, sculpture, and prestigious objects. Archaeological evidence indicates that Hatnub was already being exploited by the beginning of the Third Dynasty, while inscriptions demonstrate repeated royal expeditions during later periods. The quarry itself is not a single open pit. It is a complex industrial landscape containing extraction areas, paths, cairns, working installations, shelters, and religious features. The rock surfaces carry inscriptions written or carved by expedition personnel. Some were executed in red pigment directly against the quarry walls, while others appear as graffiti or formal stelae. Their survival is especially valuable because they preserve the names, titles, activities, and circumstances of individuals who participated in the exploitation of the site. Among the most important discoveries is the access route associated with Quarry P. The structure consists of a central ramp flanked by staircases. Along portions of those stairways are numerous holes cut into the rock. At first glance, they might seem like incidental damage left by quarrying. Their repeated arrangement suggests otherwise. Archaeologists have interpreted them as post holes, potentially accommodating wooden supports used in a hauling system. The physical arrangement is crucial. The central slope rises from the quarry, while the stairways provide workers with parallel routes along its sides. The University of Liverpool and French Institute of Oriental Archaeology teams reported that parts of the ramp reach inclines of approximately 22%. Such a gradient is substantial. Moving a heavy stone block upward on a simple sledge would have demanded considerable pulling force, especially if the surface offered significant resistance. This is where the evidence begins to connect with the mechanics of Egyptian stone transport. Imagine the basic problem without adding anything speculative. A block rests on a wooden sledge. Ropes are attached. Workers stand along the slope, and the load must be raised. On a gentle incline, a hauling team can pull directly. On a steeper slope, however, the required force rises, and maintaining control becomes increasingly difficult. The post holes provide a possible solution. One reconstruction proposes that wooden posts were positioned along the sides of the ramp and that ropes could be attached around them. Instead of relying entirely on forward pulling, workers could use the posts to create a more controlled hauling arrangement. The system may have allowed teams to pull incrementally, redistribute tension, or prevent the sledge from sliding backward when progress temporarily stopped. Researchers have described the arrangement as potentially involving a basic pulley or rope system, although the precise mechanical configuration remains under investigation. That qualification matters. The archaeological evidence does not preserve the original wooden posts or ropes. Organic materials would rarely survive in such an exposed desert environment. What remains are their negative impressions, the holes cut into stone. From those fixed points, archaeologists can reconstruct possible arrangements, but not every detail of the original mechanism. Even so, the pattern is difficult to ignore. The post holes occur within an engineered hauling route rather than randomly across the quarry. The stairways run beside the central ramp. The entire structure appears designed around the controlled movement of heavy material. The most economical interpretation is therefore that the route was deliberately engineered to solve a transportation problem. The inscriptions add another layer. Hatnub preserves a substantial corpus of texts associated with royal expeditions. Earlier work documented dozens of inscriptions, while the modern Hatnub epigraphic project has significantly increased the known corpus. Researchers report that the project has expanded the documented inscriptions and graffiti from earlier totals of roughly 60 to around 160 epigraphic features. Many remain difficult to read because the red pigment has faded and the quarry walls are uneven and weathered. These markings are not equivalent to modern engineering plans. Most were not intended to explain mechanical procedures in systematic technical language. Instead, they commemorate expeditions, identify individuals, record royal authority, and preserve statements connected with the quarrying enterprise. Their value comes from context. A royal name carved into a quarry wall establishes political involvement. A title identifies an official. A dated expedition links activity to a particular reign. A working route preserves the physical infrastructure. When these forms of evidence are examined together, the quarry becomes more than a source of stone. It becomes a record of how the Egyptian state organized access to valuable resources. Some inscriptions at Hatnub date to the reign of Khufu, the 4th dynasty king associated with the Great Pyramid at Giza. Their presence is particularly significant because the newly documented hauling system also belongs to the period of Khufu. The University of Liverpool notes that the ramp's dating creates an opportunity to examine technologies that may have been available during the construction of the Great Pyramid. This does not mean the Hatnub ramp was used to construct the Great Pyramid. That distinction is essential. Hatnub is hundreds of kilometers from Giza, and its ramp was designed for a specific quarry environment. The material extracted there was primarily calcite alabaster, whereas much of the Great Pyramid consists of limestone, with granite used in selected internal and structural elements. A quarry transport system therefore cannot simply be transferred to Giza as though it were a complete construction blueprint. What it can provide is technological evidence. If Egyptians working under Khufu were capable of engineering a steep hauling route equipped with fixed points for ropes, then the basic principles of controlled heavy load movement were available during the same historical period in which the Great Pyramid was being constructed. From there, a reasonable inference emerges. The famous pyramids may not have depended upon one single ramp design. Different stages and environments could have required different solutions. Quarry ramps, temporary embankments, sledges, ropes, water, levers, and perhaps various forms of mechanical assistance could have been combined according to local conditions. This is more consistent with the archaeological record than the idea of a universal Egyptian ramp. Alternative interpretations have nevertheless attracted attention. Some popular accounts have presented the Hatnub discovery as the missing technology that finally explains how the pyramids were built. The evidence is not strong enough for that claim. The excavated structure demonstrates a sophisticated hauling arrangement, but it does not establish that the same system operated at Giza, nor does it explain how blocks were raised through the full vertical height of the Great Pyramid. A more restrained interpretation is considerably stronger. Hatnub demonstrates that Old Kingdom Egyptians engineered their transportation systems around the physical demands of the terrain. The ramp's steep gradient, staircases, and post holes suggest that they understood the importance of controlling tension and reducing the difficulty of moving heavy loads uphill. The system represents practical engineering developed for a real industrial problem. There is also something revealing about the relationship between writing and machinery here. The inscriptions preserve human identity. The ramp preserves physical technique. One tells us who participated. The other shows something about what they did. Neither category is complete alone. Together, they allow a more detailed reconstruction of the quarrying enterprise. The wider landscape reinforces that impression. Archaeologists have identified ancient paths connecting the quarry region with the Nile, along with cairns, shelters, stoneworking areas, and simple dry stone structures. The quarry was therefore embedded in a transportation network extending beyond the extraction face itself. The most plausible picture is consequently not of a single ingenious invention suddenly appearing in Egypt, but of accumulated practical knowledge. Workers confronted steep slopes, heavy stone, limited traction, and long-distance transport. Over generations, those problems encouraged increasingly organized solutions preserved only partially in stone, pigment, and scattered archaeological traces. At Hatnub, the inscriptions and ramp belong to the same world, a state capable of sending expeditions into remote desert country, extracting valuable stone, recording the people involved, and constructing infrastructure specifically adapted to moving that stone. The exact arrangement of the ropes, posts, and sledges remains uncertain, and the connection to pyramid construction must remain an inference rather than a demonstrated fact. Yet, the evidence strongly favors an Egyptian workforce using deliberate mechanical planning rather than relying on undirected physical strength alone. In that sense, the Hatnub ramp adds another quiet piece to the larger reconstruction, one in which the monumental achievements of the Fourth Dynasty emerge from a chain of carefully engineered, intensely practical decisions. The steep paths of Hatnub showed how Egyptian workers could adapt stone transport to difficult terrain, turning a slope into an engineered route and marking the surrounding rock with records of royal expeditions. Far closer to the Nile, another quarry landscape reveals a different part of the same system. At Tura, the evidence is quieter. Pale limestone faces, cut galleries, abandoned extraction areas, and inscriptions that preserve the administrative memory of one of Egypt's most important sources of building stone. The Tura quarries lie on the eastern bank of the Nile, opposite the ancient capital region of Memphis. Today, much of the landscape has been transformed by Cairo's expansion, but the underlying geology remains significant. The limestone here is unusually fine and relatively bright, qualities that made it desirable for monuments whose outer surfaces were intended to appear smooth and luminous. The quarry was not simply one enormous excavation. It consisted of numerous extraction zones extending through the limestone hills. Workers opened galleries and removed blocks along natural bedding planes, leaving behind vertical faces, narrow passages, tool marks, spoil, and occasional unfinished pieces. The physical traces indicate a process that was systematic rather than random. Stone was selected, separated from the surrounding rock, shaped where necessary, and prepared for transport. That observation becomes important when considering the monuments that eventually received this limestone. At Giza, the Great Pyramid and its neighboring structures were built primarily from local limestone, but high-quality Tura limestone was used for important casing and architectural elements. The polished outer casing once formed a bright, carefully fitted surface around the rougher core masonry. Much of that casing has disappeared through later stone reuse, but surviving fragments demonstrate the quality of the material. Tura therefore occupies a particular position in the history of Egyptian construction. It was not necessarily the source of every block in a monument, but it provided a specialized material for surfaces where appearance and precision mattered. The inscriptions help reconstruct how that material entered the royal building system. Ancient quarry inscriptions are rarely technical manuals. They more often record the presence of officials, expeditions, royal names, religious formulas, work groups, and dates. Yet, those seemingly modest markings become valuable when compared with the physical quarry itself. A royal name carved into the rock establishes political authority. A title identifies the administrative hierarchy overseeing the expedition. A date places an episode within a particular reign. Together, these fragments transform a quarry from an anonymous industrial site into a documented component of state activity. Some of the most significant Tura inscriptions belong to the Old Kingdom, when the quarries were actively supplying royal construction projects. Their presence demonstrates that quarrying was closely connected to centralized administration. The king's building program required stone, and obtaining that stone required organized expeditions capable of moving people, equipment, food, and finished blocks between the Nile Valley and the quarry. This leads to a straightforward deduction. The real challenge was not merely extracting limestone. It was coordinating an entire chain of operations. A quarry worker needed tools, workers needed food and water, officials needed records, blocks had to be measured and selected. Transport teams needed access routes. Boats or other carriers had to move material toward construction areas. Each stage depended on the previous one. The Tura inscriptions therefore become most informative when read alongside evidence from sites such as Wadi al-Jarf and Hatnub. Wadi al-Jarf provides papyrus records documenting organized transport and administration during the reign of Khufu. Hatnub provides physical evidence for engineered movement of heavy stone and inscriptions associated with royal expeditions. Tura contributes another element, the extraction and identification of high-quality limestone intended for major royal architecture. Together, these sites suggest a distributed system rather than a single construction center. The pyramid at Giza may look geographically concentrated, but the resources required to build it were scattered across Egypt and beyond. Quarry landscapes, harbors, roads, workshops, storage facilities, and river transport routes formed a network that converged at the royal construction zone. This interpretation also changes how the inscriptions themselves should be understood. A carved royal name might initially appear ceremonial, perhaps no more significant than a dedication. In an industrial setting, however, it can function almost like an administrative marker. It connects the quarry with a particular reign and indicates that the extraction operation occurred under royal authority. Some inscriptions also preserve names and titles of individuals. These records provide glimpses of the people who managed or participated in the expeditions. Their presence challenges the idea that monumental construction was performed by an undifferentiated mass. Egyptian projects involved layers of responsibility: administrators, foremen, skilled craftsmen, transport workers, quarrymen, scribes, and laborers. The social structure implied by the quarry evidence is therefore significant. A large expedition required hierarchy because tasks had to be assigned and monitored. Someone had to determine which stone was suitable. Someone had to organize extraction. Someone had to distribute provisions. Someone had to record deliveries. Someone had to answer to higher officials. The inscriptions rarely describe this entire hierarchy in one place, but the recurring appearance of titles and officials allows historians to reconstruct parts of it. There are, however, limits. It would be misleading to treat every inscription as a direct record of the quarry's daily operations. Some were commemorative. Others may have had religious purposes. Some could have been created during brief expeditions without representing permanent occupation. The survival of inscriptions is also highly selective. Stone preserves writing, but it does not preserve every conversation, instruction, or calculation that once accompanied the work. Alternative interpretations sometimes give the inscriptions a more dramatic role, suggesting that they encode hidden information about the precise methods used to build the pyramids. Such claims generally exceed the evidence. The texts are valuable precisely because they are ordinary records of royal activity. They illuminate the organization surrounding construction, rather than revealing a concealed architectural formula. A more useful approach is comparative. At Hatnub, the physical infrastructure demonstrates that Egyptian engineers were capable of adapting hauling methods to steep terrain. At Wadi al-Jarf, administrative papyri reveal the movement of materials and personnel. At Tura, quarry inscriptions connect the extraction of valuable limestone to royal building programs. The same pattern keeps returning. Monumental construction depended on coordination between distant locations. There is also a geographical logic behind Tura's importance. The quarries were positioned near the Nile, giving extracted stone access to one of Egypt's most efficient transportation systems. A heavy block moved overland could be difficult to transport for long distances. A block transferred to a boat could potentially travel much farther with less resistance. The Nile therefore functioned as a natural logistical corridor, linking quarries with major settlements and construction zones. This does not mean every Tura block traveled by the same route. Local terrain, river levels, seasonal conditions, and construction schedules would have influenced transportation. But the proximity of the quarries to the Nile provided an obvious advantage and helps explain their sustained importance. The quality of Tura limestone offers another clue. Royal monuments demanded not merely large quantities of stone, but different grades of material for different purposes. Rougher limestone could form internal masonry where appearance was less important. Fine Tura limestone could be reserved for casing or carefully finished architectural surfaces. This suggests a degree of material classification, another indication that Egyptian construction was based on planning rather than indiscriminate extraction. Seen from this perspective, the quarry inscriptions become fragments of a much larger administrative landscape. They do not reveal every stage of pyramid construction, and they cannot independently explain the engineering methods used at Giza. Their value lies elsewhere. They establish that the Egyptian state repeatedly organized expeditions into Tura, extracted high-quality limestone, marked royal involvement, and integrated quarry production into broader architectural programs. The most plausible interpretation is therefore cumulative. Tura was a specialized industrial resource operating within a centralized system in which stone quality, labor, administration, and transport were carefully coordinated. The inscriptions preserve pieces of that structure, while the quarry itself preserves the physical evidence of extraction. What remains less certain is the precise scale of individual expeditions, the exact routes followed by particular blocks, and how much of the administrative machinery has disappeared without leaving a trace. Yet, when Tura is placed beside the transport evidence from Hatnub and the papyrus records from Wadi al-Jarf, a consistent pattern begins to emerge. The great monuments were supported by an extensive infrastructure stretching across the landscape, with inscriptions serving as small but durable markers of the people, authorities, and expeditions that kept that system moving. From Tura, the evidence carried us through carefully selected limestone toward the administrative world that supplied royal monuments. Farther south, the landscape changes completely. The Nile narrows around the first cataract. Granite rises in immense, dark masses, and the quarry faces of Aswan preserve a different kind of record. Here, the stone itself becomes a document, cut surfaces, unfinished blocks, tool marks, royal names, and hundreds of inscriptions left by expeditions moving through Egypt's southern gateway. The Aswan quarries occupy a dramatic setting beside the Nile. Unlike the relatively workable limestone of northern Egypt, granite is exceptionally hard, dense, and resistant. Ancient Egyptian builders valued the Aswan region precisely because it supplied this difficult material on a large scale. The quarries produced stone for architectural elements, statues, obelisks, sarcophagi, and other monuments whose durability depended upon the properties of granite. UCL notes that Aswan was the principal Egyptian source where hard stone was quarried on a scale comparable with the major limestone and sandstone regions. The physical evidence is immediately practical. Rock faces remain covered with channels, partially separated blocks, abandoned sections, and surfaces bearing the marks of extraction. Some areas show where stone was removed from the bedrock, while others preserve unfinished pieces that never completed their journey. The most famous example is the unfinished obelisk, an enormous monolith still attached to the quarry floor. The Ministry of Tourism and Antiquities estimates that, had the obelisk been completed, it would have reached roughly 42 meters and weighed about 1,168 tons. It is generally attributed to the reign of Hatshepsut, around the 15th century BC, and appears to have been abandoned when cracks and flaws became evident in the granite. That abandoned monument is valuable precisely because it stopped halfway. A finished obelisk tells us what Egyptian craftsmen achieved. An unfinished one exposes stages that normally disappear. The quarry floor preserves the negative space around the monument, the unfinished lower surface, and the point at which the project was halted. In effect, the failure became archaeological evidence. The same principle applies to the quarry marks. Some marks are physical rather than written. Lines indicating intended cuts, surfaces prepared for removal, traces of pounding or splitting, and irregularities created during extraction. Others are deliberately carved inscriptions. The combination allows researchers to separate natural fractures from human intervention and planned extraction from accidental breakage. The sequence can be reconstructed logically. First, suitable granite had to be identified. Then, unwanted material surrounding the intended block was removed. The extraction process had to follow the structure of the stone while avoiding major flaws. Once sufficiently isolated, the block could be shaped and prepared for transport. At each stage, the quarry workers were negotiating with the geological properties of the rock rather than simply imposing a predetermined shape upon it. The unfinished obelisk demonstrates how consequential that relationship could become. A hidden fissure could invalidate an enormous investment of labor. The decision to abandon the monolith was therefore not necessarily evidence of incompetence. Quite the opposite. Recognizing a structural defect before transportation could prevent an even greater loss of time and resources. This becomes especially important when considering the scale of Egyptian stone projects. A block of granite weighing many tons could not simply be extracted and left in place. It had to be moved from the quarry to the river, loaded onto transport vessels, carried downstream, unloaded, and incorporated into a monument. The Ministry of Tourism and Antiquities notes that massive stones from southern quarries were transported by ship toward monuments farther north, and archaeological evidence includes ancient keys associated with this movement. The quarry marks therefore belong to a larger logistical chain. They represent the point where geological material became an engineered object. Then there are the written inscriptions. Around Aswan and the nearby islands, hundreds of rock inscriptions and royal cartouches survive. Siho Island, positioned upstream from the first cataract, contains a particularly dense concentration. The ministry describes it as a granite quarry region and a stopping place for royal armies and trading expeditions traveling toward Nubia. Its inscriptions range from the Middle Kingdom through the Greco-Roman period. This distribution is significant. If inscriptions appear repeatedly along quarry routes and river passages, their presence may reflect more than individual expression. They can mark movement through a landscape. Officials, soldiers, quarry workers, administrators, and expeditions left traces that establish connections between otherwise distant places. UCL's records of Aswan inscriptions include royal names from the Old Kingdom, including Pipi I, Unaz, and Pipi II, as well as later rulers from the Middle and New Kingdoms. The same landscape was therefore repeatedly revisited across centuries. That continuity suggests something important about the quarry system. Aswan was not exploited for a single monumental campaign and then forgotten. Its geological resources remained valuable across successive dynasties. The inscriptions accumulate because different generations repeatedly entered the same landscape for related purposes. A royal cartouche carved into granite can consequently serve as a chronological marker. It tells us that an expedition or official presence was associated with a particular reign. When multiple names appear in the same region, the quarry becomes almost a layered archive, recording changing political periods without requiring a continuous written narrative. Yet, these inscriptions must be interpreted carefully. Not every mark represents a construction order. Some were commemorative. Others were connected with religious devotion or personal identity. Some may have recorded the presence of officials rather than the precise work being performed. The safest interpretation comes from combining the text with its physical location. An inscription beside a quarry face has a different evidentiary value from one positioned near a temple or sacred boulder. This distinction becomes particularly relevant at Sahel Island. The island contains hundreds of inscriptions, including royal cartouches and texts associated with officials. Some were carved into large granite boulders, while others occur within the area of the Temple of Anuket. The landscape therefore combined industrial, military, commercial, and religious activity. The boundaries between these functions were not necessarily rigid. A quarry expedition could also be a royal expedition. A journey toward Nubia could pass through a sacred landscape. Officials responsible for construction might leave commemorative records at places associated with local deities. The inscriptions consequently reveal not only administration, but the cultural meaning attached to movement through the southern frontier. One particularly revealing inscription belongs to the reigns of Hatshepsut and Thutmose III. According to the Egyptian Ministry of Tourism and Antiquities, it records an overseer of construction works associated with the extraction of 6 obelisks from the Aswan granite quarries. The wording matters because it connects written testimony with an immense physical undertaking. 6 obelisks imply repeated extraction, coordination, and transport. The inscription does not provide a complete engineering manual, but it confirms that the movement of exceptionally large granite monuments was understood as an organized state project. This creates a useful comparison with Hatnub. At Hatnub, the surviving ramp suggests that Egyptian workers could engineer specialized hauling systems for difficult terrain. At Aswan, the geology itself created a different problem. Granite required forceful extraction and careful management of fractures. The solution was therefore unlikely to have been one universal method. Egyptian quarrying appears better understood as a collection of techniques adapted to stone type, terrain, object size, and intended destination. Alternative theories sometimes treat the Aswan quarry marks as evidence for technologies far more advanced than conventional archaeology allows. Some interpretations point toward the remarkable precision of granite surfaces and the enormous dimensions of abandoned monuments, suggesting that the known tools may not fully explain the achievement. There is a reasonable observation underneath this argument. Granite is genuinely difficult to work, and the scale of some projects is extraordinary. But the stronger archaeological approach is cumulative rather than speculative. Experimental work, surviving tool marks, unfinished monuments, quarry debris, and comparisons with completed objects allow researchers to reconstruct techniques without requiring an unknown technology. The absence of every tool used at every stage does not automatically indicate a missing technological system. The quarry itself supplies an important corrective. Ancient workers did not have to carve a 1,000-ton monolith into its final form while it stood isolated in the desert. They could exploit natural fractures, remove material progressively, select favorable sections of stone, and abandon flawed pieces before investing in transportation. The unfinished obelisk demonstrates exactly how geological judgment could shape the construction process. There is also an economic dimension. Granite was valuable because it was difficult. Transporting it north required enormous effort, which means its use was probably selective. Hard stone could be reserved for elements requiring durability, prestige, or symbolic importance. This helps explain why granite appears prominently in certain architectural and funerary contexts, while limestone remained the dominant building material across much of the Nile Valley. Aswan was therefore more than a quarry. It was a resource zone, transportation gateway, military passage, and cultural landscape positioned near the southern frontier of Egypt. The ministry describes Aswan as the southern gateway of Egypt and a major link between Egypt and Nubia, while Elephantine and surrounding islands preserve inscriptions documenting expeditions traveling to the quarries and toward Nubia. Seen in this wider context, the quarry marks become less mysterious, but more revealing. They do not appear to be a secret code explaining every technique of Egyptian monument building. Instead, they preserve fragments of an industrial process and the human presence surrounding it. A cut in the granite indicates a technical decision. An abandoned monolith records a failed stage. A royal cartouche establishes political authority. A dated inscription identifies an expedition. A concentration of markings along the river reveals repeated movement. The most plausible reconstruction is therefore one of accumulated practical knowledge operating within an organized state system. Aswan supplied a difficult but exceptionally valuable material. Quarry workers adapted their methods to the stone. Officials organized expeditions. Inscriptions recorded authority and presence, and the Nile provided the essential corridor connecting southern quarries with monumental centers farther north. What remains uncertain is the precise technique used in every extraction phase, the organization of individual work crews, and how particular blocks traveled from specific quarry faces to their final destinations. Some marks remain difficult to interpret, while many vanished records were almost certainly written on materials that could not survive. Yet, the surviving granite keeps enough evidence to show something fundamental. Long before a polished obelisk stood in a temple precinct, its history was already being written into the quarry floor. One cut, one fracture, one inscription, and one abandoned decision at a time. The granite quarries of Aswan showed the beginning of the process. Raw stone, separated from the earth, measured against its natural fractures, and prepared for a journey along the Nile. Yet, the quarry alone cannot tell us how Egyptian builders organized the final stages of monumental work. For that, another kind of evidence survives on the walls of a tomb at Giza. There, the scene associated with Debhen offers a quieter view of construction, not of a pyramid being raised, but of the workers, supervisors, materials, and practical decisions surrounding a royal monument. The tomb of Debhen lies in the Western Cemetery at Giza, within the enormous funerary landscape created around the pyramids of the 4th dynasty. Its setting is important. The great royal monuments dominate the plateau, but the surrounding mastabas preserve evidence for the people who served the institutions responsible for creating them. Debhen was an official who lived during the reign of Menkaure, the king associated with the smallest of Giza's 3 principal pyramids. His tomb, conventionally designated LG90, preserves inscriptions and reliefs connected with his career and funerary provisions. Among its most interesting features is a representation involving construction activity and the movement of stone. The scene does not present a giant mechanical device or an extraordinary machine. Instead, it is composed of ordinary elements: workers, tools, stone, supervisors, and the organized movement of materials. That apparent simplicity is precisely what makes it useful. When a monumental complex is viewed from a distance, the finished architecture can appear almost independent of human effort. The pyramid becomes geometry, the temple becomes stone, the causeway becomes a straight line across the plateau. Debhen's tomb shifts the focus downward, toward the labor that transformed quarried material into architecture. The first observation concerns organization. Egyptian construction scenes rarely show workers acting as an uncontrolled crowd. Figures are arranged into groups, often performing distinct tasks. Some transport materials. Others shape stone. Supervisors stand apart from the main labor force. Tools are represented with enough clarity to identify basic activities such as cutting, carrying, measuring, and finishing. This arrangement suggests a division of labor. That inference is consistent with other Old Kingdom evidence. Large royal projects required specialized skills that could not be replaced simply by increasing the number of workers. Quarrying demanded knowledge of stone. Transport required coordinated teams. Masons needed to prepare blocks accurately. Surveyors and administrators had to establish measurements and schedules. The Debhen scene therefore fits a broader pattern. Egyptian monumental construction depended upon organization as much as physical strength. The historical context makes the evidence more significant. Menkaure's pyramid complex was constructed during the later 4th dynasty, when royal architecture at Giza had already developed through the projects of Khufu and Khafra. The Egyptians were therefore working within an established tradition of large-scale construction. The techniques visible around Menkaure's monuments were not necessarily invented for that single project. They may represent accumulated knowledge refined through earlier royal building programs. Debhen's position within that society adds another layer. His tomb emphasizes his relationship with the royal building system and his access to the institutions surrounding the king. The inscriptions associated with him help establish that officials could derive status from their participation in royal projects. Construction was consequently not merely an economic activity. It was also a mechanism through which individuals demonstrated loyalty, competence, and proximity to royal authority. The physical landscape supports this interpretation. The Giza Plateau was not simply a collection of pyramids. It contained quarries, workers' settlements, bakeries, storage areas, workshops, roads, harbors, administrative spaces, temples, and cemeteries. Excavations in the area have revealed evidence for large-scale provisioning and organized labor. The construction site therefore functioned as a complex urban-industrial environment. Debhen's tomb provides a human-scale reflection of that larger system. A worker depicted carrying material is not an isolated individual. He belongs to a team. The team belongs to a project. The project belongs to a royal institution. And that institution draws resources from a much wider network extending toward quarries such as Tura and Aswan. This connection becomes especially useful after examining the quarry evidence. At Tura, fine limestone was extracted for important architectural surfaces. At Aswan, hard granite was obtained for monuments requiring exceptional durability. At Hatnub, calcite alabaster was quarried and transported through specialized routes. Wadi al-Jarf reveals administrative records associated with the movement of materials. The Debhen scene belongs at the receiving end of this chain, where materials became part of an architectural program. The process can therefore be reconstructed as a sequence. Stone was identified and extracted. It was separated, shaped, and prepared. Transport teams moved it toward the Nile or along prepared routes. Boats and overland crews carried it closer to the construction zone. At Giza, specialized workers incorporated it into buildings, pavements, temples, and monumental structures. The finished pyramid represents only the final stage of this much longer process. There is an important complication, however. The exact activity shown in the Debhen scene has been interpreted in different ways, and not every construction image should be treated as a literal snapshot of a specific event. Egyptian tomb decoration had religious purposes. Scenes could represent idealized abundance, professional identity, ritual expectations, or the continuation of activities into the afterlife. This means the image should not automatically be read as photographic documentation. That is where comparison becomes essential. If a depiction shows a worker pulling a block, and independent archaeological evidence demonstrates that Egyptians used sledges and organized hauling teams, the image gains practical significance. If the same scene were the only evidence available, interpretation would have to remain much more cautious. The strength of Debhen's evidence lies in its agreement with a wider archaeological pattern. Old Kingdom sites preserve stoneworking tools, quarry marks, transport infrastructure, unfinished blocks, settlement remains, and administrative evidence. Together, these sources demonstrate that the physical activities represented in tomb art were grounded in real occupations. The alternative interpretation is more symbolic. Some Egyptologists emphasize that tomb scenes were designed to guarantee the deceased's continued access to labor, food, and status in the afterlife. A construction scene could therefore represent Debhen's participation in royal works without necessarily documenting one precise construction episode. The workers may symbolize an ideal workforce available to the tomb owner beyond death. That interpretation does not eliminate the historical value of the scene. Even an idealized representation reveals how Egyptian society conceptualized labor. The figures are organized, the tasks are differentiated, and the relationship between official and worker is clearly structured. The image, therefore, preserves social information even when its immediate purpose was funerary. A more speculative possibility is that such scenes were deliberately selected because they communicated technical competence. An official involved in royal construction could display that connection in his tomb as evidence of prestige. The imagery would then serve two purposes simultaneously: supporting the deceased's eternal needs and demonstrating his professional identity. This dual function fits the broader character of Egyptian tomb decoration. The walls were not neutral archives. They were carefully designed environments in which social status, religious expectations, and practical occupations could coexist. The question of labor organization is equally important. Older popular narratives often imagined pyramid construction primarily through the image of enslaved masses. Archaeological evidence from Giza presents a more complicated picture. Excavations around the workers' settlement have revealed organized housing, food production, animal remains, craft activity, and evidence of a workforce supplied by the state. This does not mean that every worker enjoyed equal status or conditions, but it suggests a system more structured than a simple slave labor model. The Debhen scene fits that hierarchy. Supervision appears alongside physical labor. This indicates that the organization of construction required levels of command. Someone had to assign tasks, maintain schedules, inspect materials, and report progress. The presence of specialized workers also suggests training. Stone cutting is not an activity that can be mastered instantly. Accurate shaping, tool maintenance, surface finishing, and measurement require practical knowledge. The survival of sophisticated masonry therefore implies transmission of skills across generations. The same principle applies to transportation. A heavy block must be moved with coordinated force. The hauling team needs rhythm. The route must be prepared. The load must remain stable. The workers must respond when resistance changes. These are forms of embodied knowledge, techniques learned through experience rather than necessarily written down. Debhen's tomb captures that knowledge indirectly. Its figures do not provide measurements or mechanical equations. They show people performing tasks within an organized environment. For modern researchers, the image becomes one piece of evidence within a larger reconstruction. There are still significant limitations. The scene cannot establish the exact dimensions of the objects represented. It cannot tell us the precise number of workers employed throughout the entire pyramid project. It cannot independently determine whether every activity shown occurred exactly as depicted. Nor can it reveal every stage between quarry and monument. But those limitations do not make the evidence insignificant. They define how it should be used. The most reliable interpretation treats the Debhen scene as visual evidence for the social and practical world surrounding Old Kingdom construction, rather than as a complete technical blueprint. It supports what the archaeological record already suggests. Royal building projects relied upon organized labor, specialized skills, supervision, and carefully managed materials. Placed beside the evidence from Wadi al-Jarf, Hatnub, Tura, and Aswan, the scene becomes part of a much larger chain. Wadi al-Jarf reveals administrative records. Hatnub reveals engineered hauling infrastructure. Tura reveals specialized limestone extraction. Aswan preserves the difficult process of granite quarrying. Debhen's tomb brings the focus back to the people who transformed these resources into architecture. The resulting picture is neither simple nor entirely complete. Egyptian monument building appears to have been a coordinated system in which physical strength, technical knowledge, administrative control, and religious purpose operated together. The Debhen scene may contain idealized elements, but its underlying organization corresponds closely with what is known from archaeological evidence elsewhere at Giza. What remains uncertain is precisely how much of the image reflects one specific construction episode and how much represents an idealized vision of professional activity. The distinction may never be fully recoverable. Yet, the balance of evidence suggests that the scene is most useful not as a secret explanation for pyramid construction, but as a small window into the human machinery surrounding it, where stone, labor, hierarchy, and technical knowledge converged long before the finished monument became the silent object we recognize today. The pyramid builder's quarry marks brought the investigation down to the smallest traces. Quick strokes of pigment, crew names, and practical signs left on stone before later masonry sealed them away. Yet, those marks tell only part of the story. To see how Egyptian craftsmen actually transformed raw material into finished objects, the evidence must move forward in time and into a different setting. At Thebes, the tomb of Rekhmire preserves an unusually detailed visual record of workshops, where stone passes through many stages before becoming something worthy of a temple or royal monument. The tomb lies on the western bank of the Nile, within the vast necropolis of Sheikh Abd el-Qurna. Its walls occupy a series of rock-cut rooms overlooking the ancient Theban landscape. Outside, the cliffs rise sharply above the valley. Inside, the surfaces are covered with painted and carved scenes arranged in carefully ordered registers. Nothing about the setting resembles a quarry. There are no enormous detached blocks lying across a desert floor. Instead, the walls show people at work, craftsmen seated beside their materials, tools held against stone, vessels being shaped, metals being processed, wood being cut, and officials supervising the movement of goods. This is a workshop world translated into funerary art. Rekhmire himself was one of the most powerful officials of the 18th dynasty. He served as vizier during the reigns of Thutmose III and Amenhotep II, around the 15th century BC. His position placed him close to the center of royal administration, and the decoration of his tomb reflects that status. The scenes are extensive enough to function almost like an illustrated catalog of production. Stoneworkers appear among other specialized craftsmen. Their actions can be divided into recognizable stages: rough shaping, cutting, smoothing, and finishing. The artists represent tools in the hands of workers, materials at different stages of completion, and craftsmen arranged according to distinct tasks. The first important observation is therefore simple. Stoneworking was not treated as one undifferentiated activity. A block had to be selected. Its unwanted material had to be removed. Its shape had to be controlled. Surfaces had to be smoothed. Details had to be refined. Finally, the object had to be inspected or incorporated into a larger architectural setting. The sequence is not preserved as a written technical manual, but the visual arrangement strongly suggests a production process divided among specialists. That inference becomes stronger when the tomb scenes are compared with physical evidence from Egyptian workshops and quarries. Unfinished statues found at Egyptian sites reveal objects abandoned at different stages of manufacture. Quarry surfaces preserve extraction marks. Stone fragments reveal repeated shaping and finishing. Tools recovered archaeologically correspond with many of the basic actions represented in the tomb. The images therefore exist within a material world that can be independently tested. Yet Rekhmire's paintings require caution. They were created for a tomb, not an industrial archive. Egyptian funerary decoration had religious purposes. Images of craftsmen could help provide the deceased with an eternal supply of objects, food, and services. A workshop scene could therefore represent idealized production, rather than one specific workshop operating on one particular day. This symbolic dimension does not make the scenes historically useless. It changes what can safely be extracted from them. The paintings may not tell us exactly how many craftsmen worked together in one room, but they clearly show that stoneworking was understood as a specialized occupation. They may not preserve the precise dimensions of a tool, but they show which kinds of actions were associated with particular stages of production. And this distinction becomes increasingly valuable when the scenes are examined as a sequence. A craftsman working a block with a hammer and cutting tool is performing an operation that removes material. Another worker appears to be engaged in a more delicate phase. The progression from rough material toward refined form reflects a fundamental principle of stoneworking. The closer an object comes to completion, the greater the need for control. Early mistakes can sometimes be corrected. Late mistakes can destroy the object. That would have been particularly important for expensive materials such as granite, basalt, or finely selected limestone. The Aswan quarries provide a useful comparison. There, the unfinished obelisk demonstrates what happened when a major flaw appeared in the stone. A massive monolith could be abandoned even after enormous effort had already been invested. The lesson is practical. Successful stoneworking depended not only on the skill of the craftsman, but also on geological judgment. Rekhmire's scenes represent the other side of that relationship. The quarry supplied material with natural properties. The craftsman had to understand those properties. The final object emerged through a controlled negotiation between human intention and the structure of the stone. This becomes particularly interesting when considering Egyptian precision. The surfaces of many surviving statues and architectural elements are remarkably smooth. Some stone vessels possess thin walls and carefully shaped openings. Granite and other hard stones were transformed into objects whose proportions can appear astonishingly exact. Alternative theories sometimes interpret this precision as evidence for machinery or technological methods unknown to conventional archaeology. The mainstream explanation is more cumulative. Ancient Egyptian craftsmen could combine hammering, pounding, cutting, drilling, grinding, and abrasive polishing. Different tools were suited to different materials and stages. Harder stone tools could be used to attack resistant surfaces, while abrasives could gradually remove material and refine the finish. No single tool needed to perform the entire operation. The effectiveness came from the sequence. This is one reason the Rekhmire scenes are more revealing when placed beside archaeological evidence rather than treated in isolation. The tomb shows recognizable actions. The workshops preserve physical remains. The quarries show where the raw material originated. The finished monuments demonstrate what the process ultimately achieved. The relationship between these four categories allows researchers to reconstruct techniques without assuming that every detail was recorded visually. There is also a social structure embedded within the scenes. Craftsmen do not appear as isolated individuals working without direction. Supervisory figures occupy distinct positions, while different occupational groups perform separate activities. This reflects a broader characteristic of Egyptian administration. Large projects required hierarchy. Someone needed to acquire raw materials. Someone needed to organize workers. Someone needed to distribute supplies. Someone needed to monitor production. Someone needed to transport finished objects. And someone needed to integrate the results into temples, palaces, tombs, or other institutions. Rekhmire's own office provides an important context for this organization. As vizier, he was responsible for major areas of state administration. His tomb decoration repeatedly emphasizes order, authority, taxation, tribute, agricultural production, craft, and the movement of goods. The stoneworkers therefore appear within a larger picture of an economy organized around institutions. Their work was not isolated from agriculture. A craftsman required food. The workshop required fuel and tools. Tools required raw materials. Raw materials came through trade, mining, quarrying, or state expeditions. Finished objects had to reach their destinations. A monument might ultimately depend upon dozens of activities occurring hundreds of kilometers apart. The scenes make this interconnectedness visible. Nearby, other workers manufacture different materials. Agricultural scenes show the production that sustains society. Foreign tribute scenes indicate the arrival of goods from territories beyond the Nile Valley. Officials supervise the accumulation and redistribution of resources. The tomb, therefore, presents something close to an administrative universe. Everything appears to have a place. This is also where the imagery becomes philosophically interesting without requiring anything supernatural. The Egyptians represented social order through productive activity. A worker shaping stone was not simply making an object. He was participating in the maintenance of a larger order. The finished statue or temple element would enter a religious environment, where it served the gods or the king. The craftsman's practical action was therefore connected to a much larger ideological structure. This helps explain why workshops appear so prominently in elite tomb decoration. Craft was valuable not merely because it produced material goods, but because it demonstrated competence within the ordered society. There is evidence that Egyptian craftsmen worked through forms of apprenticeship and inherited technical knowledge, although the surviving evidence does not justify imagining formal guilds identical to those known from much later periods. Skills had to be transmitted somehow. A worker had to learn how to hold a tool, recognize suitable stone, control pressure, prepare abrasives, and judge a surface by sight and touch. Much of this knowledge would have been practical rather than written. That creates an archaeological problem. Written records preserve words. Stone preserves marks. Neither necessarily preserves the physical experience of craftsmanship. A tomb painting can therefore provide an unusual bridge. It cannot reproduce the sensation of working granite or limestone, but it shows how Egyptian society categorized the people performing that work. Another important feature is the presence of different stone types and different degrees of finishing. Egyptian artisans did not work every material in the same manner. Limestone was relatively soft and could be shaped using techniques that would be less effective on granite. Harder stones required more intensive abrasion and different approaches to cutting and pounding. The distinction is crucial when considering claims that Egyptian craftsmen used one universal method. The evidence suggests adaptability instead. The same underlying principles could be applied to different materials, but the tools, pressure, abrasives, and time required could vary considerably. This adaptability is consistent with what has already emerged from Hatnub and Aswan. Hatnub shows an engineered transportation system adapted to steep terrain. Aswan shows quarrying adapted to exceptionally hard granite. Rekhmire shows workshop production adapted to the final transformation of materials. The recurring feature is not a single machine. It is problem-solving. The Egyptians encountered different materials and environments, then adjusted their methods accordingly. The tomb scenes also reveal how production was connected to foreign resources. Rekhmire's walls include representations of people arriving from different regions with valuable goods. These scenes are partly ideological, presenting Egypt's wealth and royal authority, but they also reflect a real historical reality. Egyptian elite workshops depended on materials that were not necessarily available locally. Metals, exotic woods, pigments, precious stones, and other resources moved through extensive networks. Stoneworking therefore existed within a broader system of acquisition and redistribution. This provides another link to the earlier Wadi al-Jarf records. Those papyri demonstrated that the movement of materials could be recorded in administrative documents. Rekhmire's tomb visualizes a different stage of the same general process. Instead of seeing a shipment recorded by a scribe, we see the craftsmen who transform resources after they arrive. The two forms of evidence complement one another. One records movement. The other represents production. Neither alone provides the entire picture. The chronology must also remain clear. Rekhmire lived many centuries after the construction of Khufu's Great Pyramid. His tomb cannot establish that the Fourth Dynasty used precisely the same workshop arrangements. Egyptian technology and administration evolved considerably between the Old and New Kingdoms. Nevertheless, continuity in basic craft principles is plausible. Stone must still be removed, it must still be shaped, tools must still be maintained. Workers must still coordinate. Supervisors must still organize production. The physical properties of granite and limestone did not change. This is where the scenes can contribute to the larger investigation without being forced into the wrong historical period. They provide evidence for the durability of a technical culture rather than a direct blueprint for pyramid construction. There is also a more subtle lesson in the unfinished objects represented and preserved elsewhere in Egypt. The finished monument encourages us to think about success. The unfinished block reveals failure. Rekhmire's craftsmen occupy the space between those two conditions. They represent the repetitive process through which success was produced. Removal, correction, smoothing, inspection, and refinement. The process would have been slow. There was no reason to hurry a statue whose purpose was intended to last for generations. The value lay in precision and durability. That changes the meaning of the apparent simplicity of Egyptian tools. A hammer, chisel, abrasive, and measuring device may appear primitive when compared with modern machinery. But technology is not defined solely by complexity. A technology can be highly effective when its tools are matched to skilled operators, stable procedures, abundant labor, and sufficient time. The Rekhmire scenes support this broader definition. Their real significance may therefore be found in the system rather than the individual tool. A tool becomes powerful when someone understands the material. A workshop becomes productive when tasks are divided. A workforce becomes effective when people coordinate. And a monumental project becomes possible when workshops, quarries, transport networks, and administrators operate within the same larger structure. The scenes do not erase the remaining uncertainties. We cannot determine precisely how closely the artistic sequences correspond to actual workshops. Some tools are stylized. Some activities may have been combined for symbolic convenience. The exact composition of abrasives, the duration of individual operations, and the organization of particular teams remain subjects for reconstruction rather than direct observation. Even so, the convergence of evidence is substantial. The quarry marks show workers identifying and organizing material. The Hatnub ramp shows controlled transportation. The Wadi al-Jarf papyri show logistical administration. The Tura and Aswan quarries show resource extraction. The archaeological workshops reveal physical production. And Rekhmire's tomb provides a visual representation of the specialists who occupied the final stages of that chain. The most plausible interpretation is therefore not that the paintings conceal a forgotten technology, but that they preserve the visible outline of an extensive craft tradition. Egyptian stoneworking appears to have depended upon specialized knowledge passed between generations, adaptable tools, careful sequencing, supervision, and an administrative system capable of supplying workshops with the materials they required. What remains beyond complete reconstruction is the invisible portion of the process, the gestures never recorded, the instructions spoken rather than written, the adjustments made when a stone behaved unexpectedly, and the accumulated experience carried in the hands of craftsmen. Rekhmire's walls preserve only a stylized image of that world, yet the image becomes more substantial when compared with the surviving tools, quarry faces, unfinished objects, and monuments themselves. Together, they suggest a culture in which extraordinary stonework could emerge not from one inexplicable breakthrough, but from thousands of controlled decisions repeated by skilled people over generations. The stoneworkers of Rekhmire showed us the final transformation of material, rough stone becoming polished vessels, statues, and architectural elements through controlled labor and accumulated skill. But before stone could be shaped, it had to reach the right place. In the Old Kingdom, one of the clearest architectural expressions of that movement was the Causeway of King Unas at Saqqara, where the practical business of transporting people and resources became part of a carefully ordered sacred landscape. The remains stretch across the desert plateau west of the Nile, where the ground rises gradually away from the fertile valley. Much of the original structure has been lost, but enough survives to reconstruct its basic character. A long enclosed passage once connected the valley temple with the upper pyramid complex. Its walls were built from stone and originally carried brightly painted reliefs. The route climbed gently toward the pyramid, creating a controlled transition from the lower landscape to the royal monument. The physical arrangement is important. This was not simply a path placed between two buildings. The causeway formed an architectural axis. Its enclosed sides restricted the view, directing attention along a predetermined route. Its floor provided a stable surface for movement, while its decorated walls transformed the journey into something more than transportation. At the upper end stood the pyramid complex of Unas, the final ruler of Egypt's 5th dynasty. His reign belongs to the 24th century BC, several centuries after the Great Pyramid projects at Giza. By this period, Egyptian royal architecture had developed into a complex combination of pyramid, temples, causeway, ritual spaces, storage areas, and supporting institutions. The causeway connected these elements. That connection gives the structure its practical significance. Heavy materials and provisions could move between different parts of the complex. Priests, workers, officials, and ritual participants could travel along the same controlled route. Goods arriving from the Nile Valley could ultimately enter the economic and ceremonial system surrounding the king's pyramid. The first deduction is therefore straightforward. The causeway was part of an operating infrastructure. Its meaning cannot be separated from movement. Stone had to arrive. Food had to be delivered. Offerings had to be prepared. Personnel had to circulate. The royal cult had to continue long after construction ended. The architecture accommodated all of these processes while giving them a religious framework. The surviving reliefs deepen the picture. Although weathering and later destruction have removed large sections, the original decorative program included scenes of agriculture, animals, hunting, transportation, tribute, ritual activity, and other aspects of Egyptian life. These images were arranged within a funerary environment, so they cannot be treated as straightforward documentary photographs. Their function was symbolic. Yet symbolism often preserves practical knowledge. A depiction of agricultural workers demonstrates familiarity with farming procedures. A transport scene reflects recognizable methods of moving goods. Animals are shown according to forms known from Egyptian economic and religious life. Ships, sledges, baskets, tools, and agricultural equipment correspond with objects and techniques documented elsewhere. The causeway therefore becomes a meeting point between representation and physical reality. A field worker shown on a wall was part of a symbolic program, but the activity itself was real. A boat represented within a funerary scene was religiously meaningful, but boats genuinely carried cargo along the Nile. A sledge could symbolize movement while also reflecting a practical technology used to transport heavy objects. This dual character is essential when reconstructing the construction environment. The pyramid complex existed between two very different landscapes. To the east lay the Nile Valley, with cultivated land, settlements, waterways, and access to river transport. To the west rose the desert plateau, where royal tombs and pyramids were constructed. The causeway physically joined these environments. That geography provides a logical explanation for its location. Large quantities of material could travel by water for much of their journey. River transport was considerably more efficient than moving heavy loads across land. Once materials reached a suitable landing point, they could be transferred onto sledges or other forms of transport and moved toward the construction zone. The causeway, or the route associated with the complex, then became the final stage of this movement. The arrangement resembles a supply chain expressed in stone. River, Valley Temple, Causeway, Upper Temple, Pyramid. Each stage had a different function. The Valley Temple could serve as an arrival and processing area. The Causeway provided controlled movement. The Upper Temple served the royal cult. The pyramid formed the central burial monument. This interpretation also explains why the causeway was so carefully constructed. A simple dirt track could have transported people and light materials, but a royal processional route required permanence. It had to remain usable, recognizable, and symbolically appropriate. The investment in stone construction and decoration, therefore, reflects more than transportation needs. It reflects the importance of the journey itself. Egyptian religious thought frequently connected the movement of the deceased king with cosmic transformation. The western desert was associated with the setting sun and the realm of the dead. A passage from the valley toward the pyramid could consequently acquire symbolic associations with movement from earthly existence toward the divine realm. This does not mean that every worker walking along the route interpreted it in the same theological manner. The practical and symbolic functions could coexist. A priest could carry an offering. A worker could move supplies. A procession could accompany a ritual. The architecture did not need to distinguish between these activities physically. It could accommodate them within one ordered environment. The scenes on the walls reinforced that order. They presented agriculture, animals, foreign peoples, resources, and royal authority within the same visual system. Egypt appears as a productive landscape whose wealth ultimately supports the king. This is partly ideological. The king's ability to receive offerings and command resources was a central element of royal representation. But the imagery also hints at the logistical reality behind that ideology. A royal institution could not receive food without agriculture. It could not build temples without stone. It could not maintain workshops without raw materials. It could not feed workers without organized distribution. The Causeway therefore belonged to a much larger economic structure. Evidence from other Egyptian sites allows this structure to be reconstructed more carefully. At Wadi al-Jarf, administrative papyri from the reign of Khufu document the movement of workers and materials associated with royal construction. At Tura, Quarry, inscriptions record activity connected with limestone extraction. At Aswan, quarry, marks, and unfinished stone demonstrate the technical processes involved in obtaining granite. At Hatnub, a ramp system provides evidence for organized movement of heavy stone through difficult terrain. The Unas complex belongs to a later generation, but it demonstrates what happened when these separate processes were brought together in a finished royal environment. The Causeway is therefore not evidence for one particular hauling method. It is evidence for the organizational framework that made monumental architecture possible. This distinction matters. Popular accounts sometimes search for a single mechanism capable of explaining pyramid construction, but Egyptian monuments were built through combinations of methods. River transport, sledges, ramps, levers, rollers in limited contexts, manpower, and carefully prepared surfaces could all have contributed at different stages. The Unas Causeway does not require a revolutionary technology. Its importance lies elsewhere. It demonstrates how movement itself was incorporated into architecture. The same principle appears in the scenes. A worker carries. An animal moves. A boat transports. A procession advances. A king travels symbolically toward eternity. The repeated theme is controlled movement, and movement requires organization. A large workforce cannot simply begin moving materials without coordination. Someone must determine where goods go, who handles them, when they arrive, and how they are distributed. The Causeway's existence implies that such coordination extended beyond the immediate construction site. Its maintenance after completion would have required an ongoing workforce. Priests needed provisions. Ritual objects required replacement. Agricultural products had to be delivered. The royal cult was designed to continue, potentially for generations. This means that the Causeway should not be understood only as a construction-era structure. Its later function was equally important. The pyramid was not abandoned when construction ended. It became the center of an institution. The institution needed personnel. Personnel needed food. Food required agriculture. Agriculture required land, labor, and administration. The physical monument therefore became part of an economic cycle. This interpretation also helps explain the abundance of agricultural imagery. The scenes do not necessarily record deliveries to Unas personally. Instead, they symbolically establish the abundance required to sustain the royal cult. Fields, animals, workers, and harvests appear as a visual guarantee of continued provision. The causeway becomes almost an illustrated statement of dependency. The king depends upon the land. The temple depends upon workers. Workers depend upon agricultural production. Agriculture depends upon the Nile, and the entire system is presented as an ordered expression of royal authority. There are, however, limits to what can be reconstructed. The surviving causeway is incomplete. Many original reliefs have disappeared. Later, reuse and stone removal altered the monument. Some scenes are known only through fragments or earlier documentation. Consequently, the exact sequence of images cannot always be established with confidence. There is also a danger in assuming that the scenes represent a literal itinerary. Egyptian artists often arranged imagery according to symbolic relationships rather than geographical realism. A hunting scene did not need to occur at the exact location where it was painted. A foreign delegation did not necessarily arrive at the temple in the precise manner shown. The decoration was selective. Its purpose was to construct meaning. Mainstream scholarship therefore tends to interpret the scenes as a combination of religious symbolism, royal ideology, and representations of real economic activities. Alternative interpretations sometimes place greater emphasis on technical information hidden within the imagery. Some researchers have attempted to read individual transport scenes as detailed engineering diagrams or direct records of construction practices. There is limited evidence for treating them so literally. The artists were not producing technical manuals. However, the possibility that practical knowledge influenced the imagery should not be dismissed. Craftsmen and officials lived within the same society represented on the walls. Their visual vocabulary necessarily drew from familiar activities. The strongest approach lies between extremes. The scenes are neither secret engineering documents nor meaningless symbolic decoration. They are representations created by a society in which practical work and religious meaning were deeply intertwined. The physical architecture supports this middle interpretation. A causeway required engineering. Its decoration required artists. Its operation required workers. Its ritual purpose required priests. Its construction required materials. Its maintenance required administration. Every visible feature therefore depended upon invisible labor. This becomes particularly significant when considering the pyramid itself. The pyramid often dominates modern perception, while the causeway seems secondary. For the ancient Egyptians, however, the entire complex formed one functional system. The pyramid was the burial monument. The upper temple supported the royal cult. The causeway connected the sacred spaces. The valley temple linked the complex to the riverine world. Seen this way, the causeway was not an accessory. It was the artery connecting separate components. Its construction would have required careful surveying and leveling. The route had to accommodate the natural rise of the terrain while maintaining architectural alignment. Stone blocks had to be transported, positioned, dressed, and integrated with the walls. Decorative surfaces had to be prepared after the structural work had progressed sufficiently. This creates another sequence: survey, foundation, stone transport, masonry, surface preparation, decoration, ritual activation. The final appearance concealed almost all of these stages. Only fragments survive. Yet, the fragments allow the process to be reconstructed in broad terms. The Unas Causeway therefore contributes an important piece to the larger investigation of Egyptian monumental construction. It does not reveal a lost machine or provide a complete blueprint for pyramid building. Instead, it shows how engineering, transportation, labor, administration, and religious purpose could be fused into a single architectural system. The most plausible interpretation is that the causeway served both practical and ceremonial functions from the beginning. Its route facilitated movement between the valley and the pyramid complex, while its enclosed and decorated form transformed that movement into a controlled ritual experience. The agricultural and transport imagery similarly combined real knowledge of Egyptian production with symbolic claims about abundance and royal power. What remains uncertain is the precise extent to which the causeway itself carried construction materials during different phases, how its earliest form differed from its later ceremonial use, and how closely individual scenes corresponded to actual events. Those gaps are understandable. Organic equipment has disappeared, many temporary installations left little trace, and the surviving decoration was shaped by religious intentions. Still, when the causeway is placed beside the quarry marks, transport records, quarry landscapes, and workshop scenes found elsewhere, a coherent pattern begins to emerge. Monumental construction was not a single act, but a long sequence of coordinated movements, and the stone passage leading toward Unas's pyramid preserves one of the clearest architectural expressions of that larger system. The Unas causeway leaves us with the impression of movement on a monumental scale. Stone, food, workers, priests, and ritual processions passing along a carefully controlled route toward the royal complex. But before any block could enter that system, someone had to know where it came from, who was responsible for it, and where it was meant to go. For that evidence, the investigation returns to the stone itself, down to the small marks that survived on blocks hidden inside the pyramids. High above the king's chamber of Khufu's Great Pyramid at Giza, the so-called relieving chambers form a confined and extraordinary architectural space. 5 low-ceilinged compartments were constructed above the chamber, using enormous granite beams and limestone masonry to redistribute the weight of the pyramid above. The rooms were never designed as ordinary living spaces, and access to them was extremely restricted. Yet their walls preserve something unexpectedly informal: red ochre marks. Some are painted directly onto blocks. Others appear as abbreviated signs, symbols, numbers, or short groups of hieroglyphic and hieratic forms. Among the most famous are references to Khufu, along with markings interpreted by Egyptologists as names or designations associated with construction crews. The marks are visually unimpressive compared with the polished stone surrounding them. That is precisely why they matter. They were not carved as monumental inscriptions intended to announce the king's achievements. Many appear to have been applied rapidly during construction, before the masonry above them was completed. Their rough appearance places them within the working environment rather than the ceremonial one. This distinction provides the first analytical step. If a mark was made on a surface that later became inaccessible, then the most reasonable explanation is that it belonged to the construction phase. It was useful to the people working there at that moment, even if it had no purpose afterward. The Great Pyramid contains millions of stone blocks, although the exact number depends upon how the structure is reconstructed. They varied considerably in size and material. Most of the core masonry consisted of local limestone, while finer Tura limestone was used for the outer casing, and granite from Aswan was employed in important internal architectural elements. Moving and positioning these materials required coordination. The quarry marks provide a small glimpse of that coordination. A simple painted sign could identify a crew, indicate a work area, distinguish one delivery from another, or serve as a temporary reference. It did not necessarily need to function like a modern serial number. In a large construction environment, even basic visual identifiers could help maintain order. The evidence becomes more compelling when the marks are considered as groups rather than isolated symbols. Several markings appear to have associations with work teams. The famous expressions connected with Khufu have often been interpreted as crew names, including formulations traditionally translated along the lines of Friends of Khufu or Khufu's gang. The exact reading and meaning of every sign remain matters for Egyptological interpretation, but the broader pattern is consistent with organized labor groups. This is important because it changes the image of pyramid construction. A monumental project is sometimes imagined as an enormous crowd acting almost mechanically, with thousands of people simply pulling stone toward a rising structure. The marks suggest something more structured. Teams could have had identities. Teams could have had supervisors. Different groups could have been assigned particular sections or tasks. The pyramid, in this interpretation, was not merely a mass of workers. It was a workplace divided into smaller units. That deduction fits the archaeological evidence from the settlement near Giza. Excavations at the site often associated with the pyramid builders have revealed substantial facilities for food production and labor support, including bakeries, animal processing areas, storage spaces, workshops, and residential structures. The remains indicate that large numbers of workers could be supplied through an organized system. This does not prove that every worker lived there permanently, or that the entire labor force consisted of one homogeneous population. But it demonstrates the existence of institutional capacity on a scale compatible with major royal construction. The quarry marks fit naturally into that environment. A workforce receiving materials from several sources would benefit from methods of identification. The system did not need to resemble modern bureaucracy. A painted symbol understood by a supervisor could be sufficient. A crew could recognize its own designation. A quarry worker could identify material destined for a particular project. A mason could distinguish one group of blocks from another. The marks may therefore represent the simplest visible layer of a much larger administrative process. The color itself is also significant. Red ochre was widely used in ancient Egypt for marking, sketching, measurements, and preliminary work. Its practical usefulness made it an appropriate medium for temporary construction notation. This helps explain why the marks are painted rather than elaborately carved. The intention was functional. A worker did not need to create an inscription that would survive thousands of years. He needed a sign that his colleagues could recognize immediately. Ironically, the temporary nature of the marks may be one reason they are so valuable today. A royal inscription tells us what Egyptian officials wanted to communicate publicly. A work mark can tell us something about what workers needed to communicate privately. The difference is subtle but profound. The official face of the pyramid speaks about kingship. The informal markings speak about organization. Both exist within the same structure. There is also a chronological advantage. Some of the most famous marks occur in areas that became sealed as construction progressed. Once the upper masonry was completed, later visitors had little practical opportunity to reach those surfaces. This creates a strong connection between the marks and the original construction period. The presence of Khufu's name is particularly significant because it links the monument to the king's reign. The informal markings surrounding it provide additional evidence that the Great Pyramid was being constructed as an active royal project rather than modified randomly at a much later period. But the marks should not be treated as a complete written record. They are fragmentary. Some are damaged. Others are difficult to read. A symbol may have multiple possible interpretations depending on context, and not every mark necessarily served the same function. Some could identify crews. Some could represent measurements. Some may indicate orientation or placement. Others might simply be notes made by workers for purposes that are now impossible to reconstruct. The correct approach is therefore cumulative. A single sign rarely proves much. A repeated pattern across multiple blocks becomes more meaningful. A sign appearing alongside a known royal name becomes more informative. A mark associated with a particular architectural phase can reveal something about chronology. The surrounding physical context determines how strong each interpretation becomes. This is also where comparisons with other Egyptian sites become useful. At Wadi al-Jarf, administrative papyri from the reign of Khufu record the movement of workers and materials connected with royal construction projects. At Tura, Quarry inscriptions document the extraction of high-quality limestone. At Aswan, quarry marks and unfinished stone reveal how granite was obtained and shaped. At Hatnub, inscriptions and physical remains illuminate methods of moving heavy material. At Giza, the quarry marks appear much closer to the final stage. The material has arrived at the monumental construction site, and workers are organizing it within the structure itself. Together, these sites create a chain: extraction, identification, transport, delivery, organization, placement. The quarry marks occupy one small position within that sequence. Their importance comes from the fact that they belong to the workers who physically handled the stone. This is why their informal character is so valuable. There is no elaborate theological text explaining cosmic order. There is no polished royal proclamation. Instead, there are quick signs applied to blocks. Their very simplicity suggests a practical environment. Alternative theories sometimes give the marks a more elaborate significance. Some popular interpretations have suggested that the signs encode hidden dimensions, astronomical information, secret instructions, or evidence of technological knowledge beyond conventional Egyptian capabilities. The evidence does not strongly support those interpretations. The marks generally resemble the kinds of abbreviated administrative and work-related signs expected in an active construction environment. Their irregularity is more consistent with practical notation than with a carefully designed secret code. That does not make them uninteresting. In fact, the ordinary explanation is more revealing. A highly organized construction project does not require mysterious machinery to become impressive. It requires coordination. Consider the physical scale of the Great Pyramid. Its original height was approximately 146.6 meters. Its core was built primarily from limestone, while granite was used in critical interior areas. Millions of individual pieces of stone had to be quarried, transported, positioned, and integrated into a carefully aligned structure. Every stage introduced the possibility of error. A block could arrive at the wrong location. A delivery could be delayed. A stone could be unsuitable. A crew could be assigned too many or too few tasks. A construction area could become congested. Simple organizational marks could help reduce such problems. This is a reasonable inference, even though the marks do not reveal an entire management system. The archaeology of Giza provides another important clue: evidence for food distribution. Bread, meat, fish, grain, and other provisions were processed on a substantial scale. Workers engaged in major state projects had to be fed, supplied with water, equipped with tools, and accommodated. That means the construction site itself was an economic organism. Stone was only one part. Food was another. Fuel was another. Wood, rope, copper, tools, and transport equipment all entered the system. The quarry marks are therefore best understood within a network of dependencies. A crew marking a block was participating in a much larger chain of production and administration. There is also a useful distinction between the pyramid's visible and invisible architecture. The finished monument is dominated by geometry. The hidden construction process was dominated by logistics. The pyramid's symmetry gives the impression of a single, unified act. The quarry marks reveal a fragmented reality: different crews, different materials, different tasks, different moments, different decisions. The final structure concealed these distinctions beneath millions of tons of stone. Only occasional marks survived to expose them. This makes the inscriptions almost like fingerprints. They are not a complete portrait of the builders, but they demonstrate presence. Someone stood there. Someone handled the pigment. Someone wrote the sign. Someone expected other workers to understand it. Then the block disappeared beneath another layer of masonry. For the ancient builders, that mark may have been insignificant. For modern researchers, it provides evidence that the monument was assembled through human systems of identification and cooperation. This also helps correct another common misconception, that precision necessarily implies an unknown technological breakthrough. Precision can arise from organization. Repeated measurements improve accuracy. Specialized workers develop expertise. Supervisors identify mistakes. Tools are maintained. Procedures are repeated. Time allows corrections. A complex result can therefore emerge from relatively simple individual operations when those operations are integrated effectively. The quarry marks support precisely this interpretation. They do not show the entire technique. They show the existence of an organized environment in which technique could be applied repeatedly. The workers themselves remain largely anonymous. We do not know the personal stories behind most of the markings. We cannot identify every individual who painted a symbol. We cannot reconstruct every shift or determine exactly how responsibilities were distributed. Yet their collective presence is unmistakable. The most plausible interpretation is that the pyramid builders' quarry marks represent a mixture of practical notation, crew identification, measurements, and administrative references created during construction. Their exact functions probably varied according to location and context. The marks do not appear to require hidden technological explanations, but they do reveal something easily overlooked. The Great Pyramid was a vast, coordinated workplace, and its organization extended down to the individual block. What remains uncertain is how standardized the marking system was, how many different crew designations existed, and precisely how these signs interacted with the larger administrative records that have mostly disappeared. Future discoveries could clarify whether particular markings corresponded to specific tasks, locations, or stages of construction. For now, the smallest traces remain among the most revealing. Far from the polished surfaces designed to endure, these rough strokes preserve another side of the pyramid, the temporary world of workers, supervisors, materials, and decisions, momentarily recorded in pigment before the architecture closed over them. The quarry marks left us with a glimpse of the working mind behind the Great Pyramid. Quick strokes of red ochre, abbreviated signs, and names apparently connected with organized groups of laborers. Among these markings, however, one expression has acquired an importance far beyond its modest appearance. It is associated with a group commonly rendered as the Friends of Khufu. Painted high within the Great Pyramid, the words seem to preserve something unexpectedly personal inside one of humanity's most formal monuments. The setting is as remarkable as the inscription itself. Far above the ground, inside the Great Pyramid at Giza, lie a series of low spaces constructed above the king's chamber. These are commonly known as the relieving chambers. Their architecture is dominated by enormous granite beams, arranged in successive layers, designed to distribute the immense weight of the pyramid above the chamber below. The surfaces are rough compared with the finished passages elsewhere in the monument. Here and there, red markings appear across the stone. Some are isolated signs. Others form short groups. Among them are references to Khufu, the king for whom the pyramid was built, together with expressions interpreted as names or designations for work crews. The famous phrase, often translated as Friends of Khufu, is generally understood not as a grand royal inscription, but as a work group designation. That distinction is essential. The inscription was not carved into a public facade. It was not positioned where ancient visitors could admire it. It was placed within a construction environment that eventually became sealed beneath the pyramid's masonry. Its original audience was therefore probably not posterity. It was the people working there. That observation gives us the first logical step. If a phrase appears in a restricted construction area and is written in an informal manner, the simplest interpretation is that it served a practical or organizational purpose. It may have identified a crew, a subdivision of workers, or an activity associated with a particular group. The exact grammatical interpretation remains debated, but the broader context is unusually strong. Khufu's name appears alongside other informal markings. The marks are associated with construction, and the spaces themselves were created as part of the pyramid's structural development. Taken together, these facts make a crew-related interpretation considerably more plausible than the idea of a later inscription placed there for ceremonial purposes. The expression has sometimes been rendered as "Friends of Khufu," although translations vary because the signs are abbreviated and informal. Another famous group name from the same collection has been translated in ways resembling "Drunkards of Khufu." At first glance, such names can seem almost out of place. The Great Pyramid is usually associated with absolute order, royal authority, and mathematical precision. Yet, the workers' markings suggest something more human, groups with distinctive identities and perhaps even playful or boastful names. That possibility changes the atmosphere of the monument. The pyramid was a royal project, but it was also a workplace, and workplaces contain communities. A crew name could create a sense of identity within a large labor force. If hundreds or thousands of people were divided into smaller teams, each group needed some means of recognition. A distinctive designation could serve an administrative purpose while simultaneously creating solidarity. This interpretation becomes stronger when considered alongside the archaeological evidence from Giza. The settlement associated with the pyramid builders contains large-scale food production facilities, including bakeries and areas used for processing animals. There is evidence for storage, craft production, housing, and other activities required to support a substantial workforce. This was not a temporary collection of individuals wandering toward a pyramid each morning. It was a structured environment. Food had to be acquired. Materials had to be distributed. Workers had to be organized. Tools had to be maintained. Tasks had to be assigned. And construction areas had to be supplied continuously. Within such a system, crew identity would have had practical value. A group name could help distinguish one team from another. The phrase "Friends of Khufu" may therefore represent only one small part of a much larger organizational structure. The most important evidence is not the phrase by itself, it is the context surrounding it. The markings appear in places where workers had access to the stone before the structure was completed. Some were painted rapidly in red ochre. They were therefore likely produced during construction rather than generations afterward. That timing is critical. Once the upper masonry had been completed, the interior surfaces became inaccessible. The marks were effectively sealed inside the monument. This makes them unusually valuable archaeological evidence. A later visitor could carve graffiti onto an exposed wall, but a mark buried beneath completed masonry is far harder to explain as a later addition. The workers who created it were operating during the building process itself. This is where the inscription connects directly with the quarry marks discussed previously. The two forms of evidence should not be treated as separate mysteries. They are different expressions of the same working environment. One set of marks can identify materials, teams, or construction stages. Another preserves a group name. Together, they indicate that written or symbolic communication existed within the construction site. The marks also reveal something about literacy. It would be incorrect to assume that every laborer involved in pyramid construction could read and write. Egyptian society had specialized scribes and administrators whose literacy served institutional needs. A crew designation could have been produced by someone with the necessary writing skills and then recognized by others within the workforce. This would require only limited literacy at the group level. The inscription does not therefore prove mass literacy. Instead, it demonstrates that written communication could function directly inside a major construction project. That observation fits the wider Egyptian administrative tradition. The state depended heavily upon recording quantities, deliveries, personnel, taxation, and supplies. Written documents from later periods demonstrate how deeply administration was integrated into Egyptian institutions. The Wadi al-Jarf papyri provide particularly important evidence from the same broad period as Khufu. Those records describe the movement of personnel and materials connected with royal construction. The papyri and the crew inscriptions belong to different forms of evidence. One is administrative writing on papyrus. The other is informal writing on stone, but together they point toward an organized system in which people and materials were tracked and coordinated. The Friends of Khufu designation may therefore have had a practical function within that system. Yet there is another possibility worth considering. The name may not have been purely bureaucratic. Ancient work groups could possess identities that were meaningful to their members. A collective name could communicate loyalty, competition, pride, or camaraderie. This is where the unusual wording becomes significant. If one crew called itself something comparable to Friends of Khufu, the name may have expressed an association with the king. Another group, using a more humorous designation, suggests that workers were capable of creating identities that were not simply imposed from above. Such names could have functioned like team names. The comparison should not be pushed too far, but the basic principle is reasonable. A large organization can maintain discipline while still containing smaller communities with their own identities. The royal administration provided the larger framework. The crews supplied the human structure within it. This helps explain why the phrase is more interesting than its translation initially suggests. It does not reveal a secret about pyramid engineering. It reveals something about the social organization behind the engineering. The workers were not merely anonymous physical labor. They operated within groups. Those groups appear to have been recognized by names, and at least some of those names were associated directly with the king. This also raises the question of whether such designations represented permanent teams or temporary divisions. The evidence cannot provide a simple answer. A crew could have existed for a particular stage of construction. It might have been divided into smaller units. Members could have been reassigned. A name could have been inherited by a later group. Or the designation could have been primarily symbolic. The safest interpretation is therefore flexible. The markings indicate organized groups of workers, but the exact administrative structure behind those groups remains only partly reconstructible. There is another important issue. The phrase "Friends of Khufu" should not be treated as if it were an official title equivalent to a modern military or governmental rank. The surviving graffiti are informal. Their abbreviated form makes translation difficult. Egyptian writing at the time could omit elements that would have been understood by contemporary readers but are less obvious today. Consequently, every translation should be treated as an interpretation rather than a perfectly transparent statement. Alternative theories sometimes take the phrase in a more literal or symbolic direction. Some have suggested that such names represent elite groups closely connected to the king, perhaps even specialized royal organizations. Others have interpreted the names as evidence of a highly privileged workforce. There is little direct evidence for making such claims confidently. The phrase alone does not establish social rank. It does not prove that its members were royal guards, engineers, priests, or an elite corps. The surrounding archaeological evidence provides a more restrained explanation. Organized labor groups participated in a state-sponsored construction project and used recognizable designations within that environment. This interpretation also fits what is known about Egyptian labor more broadly. The old image of pyramid construction as nothing more than mass enslavement has become increasingly difficult to sustain as a general explanation. Archaeological evidence from Giza points toward a complex workforce that included skilled specialists, administrators, craftsmen, laborers, and people engaged in supporting activities. This does not mean every worker enjoyed the same status, nor does it mean forced labor never existed in ancient Egypt. The social system was hierarchical, but the evidence indicates something considerably more organized than an undifferentiated population compelled to move stones. The crew inscriptions belong within that more complicated picture. They suggest organization at a level beneath the state but above the individual. The king stood at the summit. Administrators and supervisors translated royal projects into practical assignments. Teams carried out those assignments. Individual craftsmen and laborers performed specialized tasks. The Friends of Khufu marking sits somewhere within this middle layer. It is a small sign of collective identity embedded in a colossal expression of centralized authority. That contrast may be the most revealing feature of all. The pyramid appears to belong entirely to the king. His name defines its identity. His burial gave the complex its purpose. His authority mobilized its resources. Yet the hidden walls contain the names of groups who physically created it. The monument is royal in conception, but human in execution. The phrase also provides a useful warning against reading ancient inscriptions too dramatically. A few words can become famous because modern audiences naturally search them for extraordinary information. But archaeology often works in the opposite direction. The more closely the evidence is examined, the more ordinary the explanation can become. A crew name does not need to conceal a forgotten civilization. A red inscription does not need to encode advanced machinery. A mark inside the Great Pyramid can be important simply because it demonstrates how people organized themselves. That ordinary explanation has considerable power. Large-scale construction requires repeated coordination. Coordination becomes easier when people belong to identifiable units. Identifiable units benefit from shared designations, and shared designations can leave traces. The Friends of Khufu inscription may therefore be understood as one surviving fragment of the social machinery behind the pyramid. There are still gaps. The complete roster of crews is unknown. The precise hierarchy between different groups remains uncertain. The duration of individual team identities cannot be established with confidence. And because only a small fraction of the original markings survive, modern researchers are seeing a highly incomplete sample of what once existed. Even the phrase itself should remain connected to the broader group of markings rather than elevated into a standalone explanation of pyramid construction. The strongest interpretation emerges from the convergence of evidence. The Great Pyramid was built through a highly organized labor system, and workers operated within identifiable groups whose names could express both administrative function and collective identity. Friends of Khufu appears to belong to this world of construction teams, supervision, and royal service. Its significance, then, may lie less in the words themselves than in the fact that those words were written at all. A king's monument was meant to preserve his name for eternity. The workers' marks were never intended to survive, yet both remain together inside the same structure, one proclaiming royal power, the other quietly recording the people who stood beneath it, carrying out the countless coordinated tasks through which an immense architectural vision gradually became stone.